Welcome aboard! For today's episode, we'll dive into one of the most essential skills for deck officers and navigators, the application of the constant rate of turn techniques. I'm Jess Pascual and I will help you understand this theory and procedures. Let's get started! In accordance with the STCW Code, Table A22, Function 1, Navigation at the Management Level, the competence column focuses on maneuvering and handling a ship in all conditions, which lists the required minimum knowledge, understanding, and proficiency for officer certification to carry out their watchkeeping duties, which is the application of constant rate of turn techniques are included. So, what is the constant rate of turn technique? It is one way of keeping the ship along the track or within the boundaries of the cross-track limits set for the leg of a particular passage while turning during course alterations. This could be well achieved with a rate of turn indicator fitted on board ships. As per SOLAS Chapter 5, Safety of Navigation, all vessels greater than 50,000 gross tons shall be equipped with a rate of turn indicator. We have here an ECDIS screen display showing a route along the traffic lane of a traffic separation scheme. The initial course was 066 degrees true, and we intend to turn around the runabout of the scheme. And the next course is 343 degrees true. The planned radius of turn for this is half a mile. We know that ships do not turn as quickly as cars. Even if you put the rudder hard over to one side, the ship would still continue to move along the course line until it reaches a point where the heading starts to change. In this case, we must find the answers to the following 4 questions. At which point along the regional course should the navigator start executing the turn? Where would be the wheel over point in this scenario? If the ship drifted away from the original track, what action should the navigator take? And what is the purpose of the wheel over line? To negotiate the turn around the arc, the constant rate of turn techniques can be applied. In simple terms, the rate of turn of the ship is how fast the heading changes direction while turning along the planned arc of the turn. This is expressed in degrees per minute. Let us give an example of the application of the constant radius turn technique. Here, we have the given information. The length between perpendicular, which is 275 meters. The block coefficient, which is 0.75. The POI, or the point to overcome inertia, which is also the F distance, which is one ship's length or one length between perpendiculars. The initial course, which is 066 degrees true, and the next course, which is 343 degrees true. The planned turning radius for this route is 0.5 nautical miles or half a mile at this point. Now, how will you determine or draw on the line the turning radius? First, you have to measure half a mile from the course lines and draw lines over it. The same thing with the other course line, the original one. And then find the intersection on here. The intersection is the datum for the circle of turn. Meaning to say, if you draw a circle on here, that circle will be called the circle of turn. What is most important here is this sector, because that's the sector of the turn. This sector contains the arc of the turn. The arc of the turn is the track that the ship should follow while making the turn. Now, as you can see here, we have the line here and we have the circle. The tangency point here is what we call the point of tangency. It is actually the point where the ship should start turning. But as what we have said earlier on, that ships do not turn exactly the same as cars, as quickly as cars. So we need to make some adjustments. We have to find the point at which we start maneuvering. We can do that by finding the POI, the point of tangency. So you measure the point of tangency, one ship's length from here, and that point there could be called, or is called, the wheel over point. Now, we need to find as well the wheel over line. The wheel over line is a line drawn over the wheel over point, and it is always parallel to the next course line. The planned radius of turn for specific waypoints must be set correctly in ECDIS to ensure an appropriate display of the arc of turn. To do this, press the Planning Mode button on the taskbar panel to access the route plan. Then, access the relevant waypoint in question. Under the column Turning Radius, set the desired turn radius for the waypoint, in this case, 926 meters, which is equivalent to half a mile. Note that in some ECDISes, the figure for this setting is either in meters or in nautical miles. The master and the navigating officer must ensure that the settings for the F distance or the POI are correct based on the factors mentioned earlier, such as the length of the ship and its block coefficient. As a rule of thumb, for full-form vessels with more than 0.7 block coefficient, the setting should be equal to the ship's length between perpendiculars. Whereas for fine-form ships with less than 0.7 block coefficient, the setting should be approximately 1.5 of the length between perpendiculars. To do this, press the setting button on the taskbar panels on the right-hand side of the ECDIS screen. The required setting for the F distance is equal to the vessel's length, which is 275 meters, as the ship used in this example has more than 0.7 block coefficient. This setting is usually done during installation and initialization of the ECDIS unit. However, for safety's sake, it's worth rechecking the parameters. Now let us answer the questions we raised earlier. If the ship drifted away from the planned track, what action should the navigator take? What is the purpose of the wheel over line? The wheel over line is drawn parallel to the next course line over the wheel over point. It is helpful if the ship drifts to either side of the intended course line. It does not make sense to go back to the original course just to be able to turn the ship at precisely the point at which the original course line intersects the wheel over point. Instead, continue navigating with the present course if safe and practicable to do so, and start executing the maneuver only after reaching the wheel over line, considering the planned radius of turn and the observed ship's speed during the turn. This means that the ship is expected to follow an arc similar to the one that would have occurred had the ship initiated or started maneuvering at the wheel over point. That would bring the ship to the next course line. In case you are drifted to the other side, as in this case, you can actually maneuver exactly the same way as if you are at the wheel over point. And it will form an arc similar to that, and it will bring the ship to the next course lines. To conclude, one requirement for watch officers to carry out their watchkeeping duties is the minimum knowledge, understanding, and proficiency in applying the constant rate of turn techniques in ship handling and maneuvering. Constant rate of turn technique is one way of keeping the ship along the track or within the boundaries of the cross-track limits set for the leg of a particular passage while making a turn during course alterations. The rate of turn in degrees per minute can be calculated by dividing the speed over the ground by the turn radius. It is equally important that the radius of turn for each waypoint is encoded or set in ECDIS correctly. To obtain the appropriate starting point in a turn, the FD stand setting in ECDIS must be aligned with the relevant ship's particulars and maneuvering characteristics. The correct setting will define the wheel over point and the wheel over line. Should the ship drift to either side of the intended course line, returning to the original line is unnecessary. Instead, one can execute the turn upon reaching the wheel over line drawn on the navigational chart. This maneuver would bring the ship to the next course line. We hope you found this exploration of the constant rate of turn techniques both informative and inspiring. But this is just the beginning of your journey to mastering maritime navigation. UMTC offers a comprehensive range of deck courses designed to equip you with the skills and knowledge you need to excel in the maritime industry. From basic navigation to bridge resource management to advanced ship handling and maneuvering training, our courses are tailored to meet the needs of aspiring and experienced mariners alike. If you want to take to the next step in your career, visit our website www.umtc.com.ph and enroll in our courses. Remember to like and subscribe to our channel. This is Jess Pascual of United Marine Training Center, wishing you all friendly winds and following seas.